Okay, this is an application vector, paper 2. So I don't do paper 1 because this is a very short chapter and usually requires the usage of calculator to do it. So this is paper 2, yeah? So let's begin with question number 1. So here we have 1, 0 is a unit vector due east, that means it's your I. 0, 1 is unit vector due north, that means it's your J. So all distances are measured in meter. A cyclist moves with this constant speed in the direction of southeast. Okay, remember southeast means I'm going this direction, 45 degree. Or you can say 135, bearing of 135. Bearing is measured from north. So if this is 45, usually we don't have to use the bearing resolving the vectors into 2. We don't need to do that. We can just say this is 1 and 1, right? But the 1 here, you need to put a negative. Why negative? Because it's going right and going down. You need a negative there. So part A, when this, you're finding velocity vector, right? So your velocity vector, we put the lambda 1 minus 1. Now remember, they say it has a constant speed of 6 at 2. So meaning the magnitude of velocity is your speed. So your magnitude is 6 at 2. So what we can do is we can take lambda outside, take square root of 1 square plus minus 1 square. The result must equals to 6 at 2. Okay. Now don't have to do a lot. We'll just straight away, this is square root 2 itself. We can cancel them. Maybe I write extra step. Lambda at 2 is 6 at 2. Cancel it. Your lambda is 6. If your lambda is 6, your velocity will be 6, 1 minus 1. Multiply inside. You should get 6 minus 6. Okay. There you go. That's your velocity vector of the cyclist. All right, that is part A. So part B, given that the cyclist starts from point A with this position vector to point B with this position vector, find the time taken. So we need to find displacement first. Remember, displacement divide by time gives us your velocity. We already know our velocity vector. We need to find our displacement vector. So when you go from A to B, your displacement is AB, or we can write this as OB minus OA. My OB is 91, negative 103. My OA is negative 47, 35. Now your 91, when you plus 47, you get 138. Minus 103 minus 35, you get negative 138. Now, notice that what we can do is this. We take this velocity 6 minus 6. We equate with the displacement vector 138, 138 with a negative. But normally we don't divide by time. Because, I mean, we can divide by time, but we don't write like this over t. When you have column vector, usually instead of dividing with t, we multiply with 1 over t. Okay, so what we can do is we can simplify this. Now 138, should I just take out the whole thing or just divide by 6? We just divide by 6. 138 divided by 6, you get 23. So I'm going to factorize 23 from here, and I write this as 6 minus 6. Why do I do that? So that I can cancel this 2, and I can find the value of t, right? So you can cancel it, you can multiply the t up. T is just 23. So the time taken for the whole journey is just 23 seconds. This is second, huh? The unit is in second. Okay, you don't even have to write the unit. I just add in here 23 seconds. Question number 2, this one you're given the bearing. So we have to draw where's 244. A train traveled on the bearing of 244. 244 is more than 180, but less than 270. Now remember, bearing measure from north. So we go from here to here. This is 244. Move down towards the x-axis. 244 and 270. What's the difference? The difference is 26. So your magnitude of your velocity is called speed, and the speed is 89. And it has 2 components. Let's say the horizontal component, call it A. Vertical component, call it B. Now you can write cos first, or you can put negative, up to you. As in, A itself, right, is on the left-hand side. So I cut short my working a bit. I write this as 89 cos 26. Add in a negative in front. Why do I add a negative? Because it's on the left side. You can write cos 26 equals to negative a over 89. Also can. Now let's just use our calculator. 89 cos 26. That gives us 79.99, 80 lah. Negative 80. As for your vertical component is b, we take b equals to negative 89 sine 26. It's also negative because it's below the x-axis, right? So 89 sine 26. You should get 39.01. We'll just take negative 39. Okay, right. Your velocity is therefore minus 80 minus 39. They are both negative because it's going left and it's going down. Yeah, going left, going down. So guys, this is your answer for A. Okay, right. Now that you got your velocity vector, they say the train traveled from P with this position vector to Q with this position vector in 3 hours. Find H and K. Now, similar to question number 1, you need to find your position vector. Should I say displacement vector? Displacement vector PQ. Then you divide by the time, right? To get your velocity vector. We know the velocity vector. So let's find out your PQ first. PQ will be OQ minus OP. What's your OQ? OQ, I prefer to write in column vector. Sorry, for part A, sorry guys, we need to write in IJ form. Because the question says so. See, the question says write in this form. So I follow instruction, just change it. You can write in IJ form. Only the last step we change to IJ. Yeah, you can write in column vector, then convert to IJ, no problem. Okay, second one, let me just calculate in column vector first. Your OQ is H minus 45. Your OP is 58K. Put them together. This is H minus 58 minus 45 minus K. Now, remember this is your displacement. You divide by time, you get your velocity. I can write velocity first, negative 80, negative 39 on the left. Instead of dividing by 3, right, I write 1 over 3 times 1 over 3. Yeah, then I copy your displacement vector here. So can we multiply over? So as I multiply the 3 over 3 times 80, that's negative 240. 3 times 39 is 117. Yeah, think 40 times 3, 120. 120 minus 3, 117. This is H minus 58 minus 45 minus K. So what we want to do is when we find H and K, we compare our I component. Negative 240 is H minus 58. Bring over, that is negative 182. Right? 182. Then if you want to find K, you just compare your J component. Negative 117 equals to 45. Negative 45 minus K. Bring over 117 minus 45. What is that? 72. So your H is negative 182. Your K is 72. From town P to town Q, the position vector of the car relative to origin O is given by this. Okay, so this one is the position vector. Remember, if you have, for example, a point here, your starting point is A. Your end point is, let's say, P. If I want to go from O to P, I must go O to A, A to P, where A is your initial position. What is AP? AP is your displacement, right? So at different time, you have your different position of P. Maybe P, T equals 1, maybe P is here, T equals 2, P is here, T equals 3, P is here, and so on. You keep moving along this direction. So you write OA plus, what do I put here? AP is what? TV. Why TV? Because T is time, V is velocity, right? Remember, displacement divided by time is your velocity. Your AP is T multiplied by V. So once you know this, we sub inside. This is the equation representing the position vector of the car or whatever item or whatever object at any time. Yeah, at different time, you sub in different T values, you get the final position of the object. Okay, but you notice in this case, they actually gave us in this form already because they already substituted the velocity, which is negative 33 and 56, and the initial position 16 minus 29. Yeah. How do you know all this? You just break it up, okay? So this is a general case. I remember we discussed this before, right? This is like a starting equation that you have to form. Okay, anyway, Coming back to this question, we're supposed to find the speed. So I'm going to break this up to 2, right? Again, I like to write column vector because it's easier to see. So we write this as 16 minus 29 plus factorize the t, negative 3356. Okay, remember, this is your initial position, right? In this case, sorry, I cannot call this P. Better don't call this P because you may get confused. Can I call the car as OC? C for car. Why? Because the question says it started from town P. So this is the position vector of town P. This OP here. This is your velocity vector of the car, right? You're finding the speed. Okay, what is speed? Speed is the magnitude of your velocity. If my velocity is minus 3356, how to find your speed? We take the magnitude, negative 33 squared plus 56 square root. Okay, calculator. 33 square, 56 square root. My answer is 65. Yeah, simple. 65 what? Kilometer per hour. Okay, normally unit, no marks given, so you don't write the unit, it's fine. Just write 65. Right. Next, find position vector of Q. They say distance of PQ is 130. So how can you find, what can you find? You're given distance. You know your speed. Remember, speed is what? Speed is distance divided by time. So speed is a scalar quantity. Scalar quantity, we don't need to write vector. Yeah, guys, scalar quantity, we don't have to write all the column vector and ij. Your speed is 65. What's the distance? 130. What is the time? 130 divided 65. Answer? 2 hours, right? So it takes 2 hours for it to go from P to Q. Now, if I want to find position vector of Q, what do I do? I substitute T with 2. So let's put 16 minus 29 plus 2 minus 3356. This is 16 minus 29 plus minus 66, 112. Can we add them together? This is negative 50. 112 minus 29. What is that? 17. Negative, sorry, 87, right? Yeah. They come only 112, 17, 17. So 83. 83. Okay. All right. I've got the position vector of Q. Next, they ask us to find bearing. Bearing of Q from O. Okay, remember, bearing, right? You need to measure from north. So OQ, if you see negative 50, 83, right? What you do is we draw left by 50, down by 83. Sorry, this one 83 is positive, not down, it's up. You go left by 50, up by 83, so it looks like this. So this is your north. Okay, bearing measure from where? From north. So we go one round like this. We find out this angle first, theta. So let's take tangent. It's always tangent, right? Tangent is opposite over adjacent. Find your theta. Shift tangent. 83 divide 50. You should get 58.9. 1 decimal point to do 58.9. Now, once you get this 58.9, if you're finding bearing, this is Q from O. What do I do? Remember, bearing, unlike trigonometry, right? We go 0, 180 minus, 180 plus, 360 minus, because we measure from positive x-axis. But bearing, we measure from north. So when you measure from north, this one should be 90 plus, 90 minus. Then we go this direction, right? This is 270 minus or 270 plus. Yeah, it's not like trigo. Trigo is 180 minus and plus. Here we use 90 and 270. So in this case, I am measuring from the red line from north to 270, more than 270. So we take 270 plus 58.9. That gives us 328.9. 328.9. There you go. That's your bearing. Okay, question number 4. So in this question, all lengths are measured meter, velocities in meter per second. Particle A moves with a velocity vector of -5 I plus bj, where p is a constant, positive constant, from a point with this position vector, 21I minus 17j. The speed of particle A is 13. Find the value of p. Okay, now they give us the velocity vector. They give us the speed. So we know we have to, or we can use magnitude. So remember, velocity, it goes in this direction. It has this velocity vector. So maybe we write minus 5p. All right, I list down for you. The magnitude of your velocity is called speed. So you take this, we square root it. The result is 13. We're finding p. So this is 25, okay, plus p squared. 13 squared, 169. 169 minus 25, 144. Square root 144, p is 12. Now, do you put plus minus? No, why not? P is a positive constant, right? You don't need to put plus minus. P is just 12. All right. At the same time, particle B starts moving from this position vector, right? So after 5 seconds. So find the position vector at which both particles collide. Okay, so first we need to find where you start, where you end, right? Well, the question mentioned, we need a velocity, right? We know displacement divided by time equals to velocity. We already have the starting position of your point, a particle A, and we know the velocity, we know the time. So maybe can I say this particle A, right? What do you want to call it? I can't call it A, or should I call it A? Okay, can we say the point where they meet is P? So A to B is, you divide by time, how long? 5 seconds. What's your velocity vector? Minus 5p, p is 12. So AP will be what? Times over, what is this? Should I not write like this? Okay, I tell you what, guys, I changed my mind now. Because if I do like this, you may find it's a different way of the standard way that I always use. Sorry, I think we say the particle A, right? We say OA equals, what's your starting position? Starting position is 21 minus 17. What's the time? The time is 5 seconds. What is your velocity vector? Velocity vector is minus 5, 12. Remember, we always say OP equals to, or whatever you can call it, OP equals to, or maybe I call it OQ equals OP plus TV. What is P? P is your starting position. What is T? T is time. What is V? V is your velocity. Okay, so I just use it directly. Yeah. So OA represent the position vector of A at that time after 5 seconds. Okay. Now, can we count this? 21 minus 17 plus negative 25, 60. 21 minus 25 is negative 4. Minus 17 plus 60 is 43. Right? So there you go. That is the position vector of A. So position vector of point A is the point where they collide. Because, okay, if you want, I can just do a sketch for you. So where does A start? A start from 21 minus 17, maybe here. Okay. Where is the starting point B? B starts from negative 19 and 8. Somewhere here. B starts from here. A starts from here. B starts from here. Now, where's A moving? A is moving with this vector. Minus 5, 12. Minus 5, 12 means it's going maybe like this. Okay. So at one point, it will collide with B. B, I don't know. B is going maybe here. I don't know. Right. But we do know that the final meeting point is here. Minus 490, 43. Right. So yeah, I just call it A. You don't have to call it A. You can call it something else. Right. So this is the position vector where they collide. But to find velocity of B, right, we know now this is the point of collision. What do you want to call the point of collision? Maybe I call it R. Yeah. Actually, this is OR. You want to write OA, OR, doesn't matter. Okay. right? You can call it OR. R is your collision, the point where they meet. So we find BR first. So what is BR? BR is your displacement, right? Then we divide by time. BR is OR minus OB. What's your OR? Your OR is this, minus 443. What's your OB? OB is your starting position, which is negative 19 and 8. So find out your BR. 19 minus 4 is 15. 43 minus 8 is 35. So this is your BR. BR, you can see from my diagram, if you draw this out, it's easier to understand. It goes from here to here. So this is your displacement. Okay, I want to find the velocity. Velocity is displacement divided by time. So take this displacement, divide by time. Your time is what? Your time is the same, still 5 seconds. But instead of dividing by 5, what do we write? You times 1 over 5. So let's multiply inside. You should get 37. There you go. That's your velocity vector. You can write in IJ form, 3I plus 7J. Doesn't matter. So question 5, in this question, I is unit vector, due east, J is unit vector due north. The length are in kilometer, velocity are in kilometer per hour. Cyclists travel with this velocity on this bearing. Find the speed and the value of constant P. So when they give us bearing 240 again, we can just do a sketch. Where's 240? Start from here to here. This is 240. Okay, this will be 270. So what's the difference? Maybe I should make it bigger. 270, 240 is bigger. Like this. This angle should be 30, right? So we should break it up. They have two components, P and negative 8. So this is P, this negative 8. Now your P should be negative in value because it's on the left-hand side. You can see that, right? So we say P is, okay, what is your velocity? Sorry, what's your speed? I don't know the speed. So maybe like call it V. Let's call it V first. Okay, so we don't find P first, we find V first. So remember, you have horizontal and vertical. Horizontal is cos, vertical is sine. So we say this V is negative 8. Okay, wait. We don't put negative here for V. Why? Because velocity is, in this case, this is your speed. The magnitude of it is positive. So we just say you can write V is 8. Should I write like this? 8 is V sine 30. Or sine 30 is 8 divided by V. Yeah, 8 divided by V is okay. So you bring it down. What is your V now? 8 divide sine 30. V should be 16. 16. Okay. So now that I know V is 16, can we find P? Now remember P is negative, so you put 16 cos 30. This will be in third form. Put a negative here. Negative 16 cos 30 is sec 3 over 2. You should get negative 8 sec 3. That's your P. So guys, I got my speed, which is 16. I got my P value, which is negative 8 sec 3. All right. Now, part A, done. Part B, write down in terms of the position vector of the cyclist after T hours. Okay. We know the velocity. We know the initial position, right? We don't know the time. We have to give answer in terms of T. The cyclist, we can call it OC. It started from point A. So they give us point A. So we can write this as 11 minus 3 plus T. Multiply with its position vector. What's the position? Multiply with its velocity vector. What's your velocity? P is negative 8 sec 3. And the second one is negative 8. So guys, we got this already. So you can put it together. So it's 11 minus 8 sec 3t minus 3 minus 8t. There you go. That is the position vector of the cyclist. Next one, part C. Find the time when the cyclist reaches B and the value of constant Q. Okay, find the time when it reaches B. Okay, when will it reach B? B has this. When it reaches B, right, this position vector must now, your OC, must now equals to OB. What's your OB? Q negative 17. So what we can do first is to find the time, right? Okay, find the time. We can, okay, I think I wrote this wrongly. This one, I wrote this wrongly. This is negative 3 minus 8. Minus 3 minus 80. So can we compare these two? Minus 3 minus 80 is minus 17. Okay. Oh, quite an ugly number. What's your 80? 80 is 17 minus 3 is 14. 14 you divide by 8. 7 over 4. 7 over 4 is 1.75 hours. So what's the value of t? The time taken is 1 hour 45 minutes. You can write 1.75 because the question didn't ask you to write an hour and minute. So I'll just write 1.75. If I change to hour and minute, it's 1 hour 45 minutes. Okay, next, we need to take this and sub inside here to find our Q. Because Q is your I component. Just now I compared the J component. Next, I compare my I component. My Q is 11 minus 8 sub 3 times T. T is 1.75. So let's count. Calculator, 11 minus 8 sub 3. You times with 1.75. You get, I'll write in decimal, negative 13.2. 13.2. There you go. That's your constant Q. So Q represents what? Your I component of position vector B. So here in this question, all the lengths are in kilometer. The speed are in kilometer per hour. So a boat sails from B, from point A. Boat B sails from point A with this position vector. Velocity of boat P is this. Right now, position vector P after leaving point A. So this one is quite easy. You all know already. Your OP is OA. What's your OA? Starting position of OA is 24.6 plus T, the velocity is minus 9.13. Just put them together. You get 24 minus 9T, 6 plus 13T. Okay, so that is part A, position vector of P. Now, at the same time, boat P leaves point A. Boat Q sail with this position vector. Okay, write down the speed of Q. Okay, very simple. We break this up first. Your OQ, right, we break up into the starting point, 49, plus T, what do I write here? 6.8. So your 6.8 is your velocity. How to find your speed? You find the magnitude. 6 square, 8 square, square root. Isn't it 10? 10 what? Meter per second or kilometer? Kilometer per hour. You don't have to write the unit, right? Okay, that is part B. Part C, express displacement vector of PQ in terms of T. Okay, so we know OP, we know OQ. Displacement vector of PQ is OQ minus OP. My OQ, we already have it here, 14 plus 60, 9 plus 80. Your OP we also have, right? 24 minus 90, 6 plus 13T. So put them together. 14 minus 24 is negative 10. 6 minus 9, 6 plus 9, 15, 15J, 15T. Then 9 minus 6 is 3. 8 minus 13, negative 5. Guys, I got my displacement of PQ. Now, next, find the value of T when the distance between both P and Q is now 37 kilometers. So what we can do is we take magnitude of PQ equals to 37, right? Magnitude of your displacement is called distance. So to find distance, we just take, to find magnitude of the distance, we just take the x component, we square it, take the y component, we square it, put the square root over, the result is 37. Our job is to solve for t. So we just expand the bracket. Negative 10 squared is 100. 2 times 15 is 30. 30 times 10, 300t. 15 squared is 225 t squared. 3 squared is 9. 2 times 5 is 10. 10 times 3, 30. And 25t squared. 37, when you square it, you get 1369. So add together, 225 plus 25 is 250t squared. minus 300 minus 30 is minus 330. 100 here, you plus 9, 109 minus 1369. You will get 1260. Okay, I wonder, can we divide by 10? Can divide by 10? Definitely can divide by 10. Cancel out the 0. But this number is still a bit hard to factorize. You can use your quadratic formula, or you can, cheat using calculator. This one, yeah, this is not the secret anymore. Everybody know this menu, 5 for equation. Okay, of course, you're using the latest calculator. The button is different. 25 equals minus 33 minus 126. I got this 3 and 42 over 25. Or you can use quadratic formula. So we know it is 3 and 42 over 25. So I put a 3 here. This 25, you must times with 3. And this one must be positive, because 25 times 3 is 75. 75 minus 42 is 33. Okay, you can use your calculator to validate. Okay, right? So this t cannot be negative 42 over 25. See, 42 times 5, 126, right? Then t must be 3. So there you go. That's the answer. Okay, if you want to understand a bit better, right? Remember, this P and Q, they are all ever changing. So P may be going this direction, right? Just a sketch. Q may be going this direction. But at one point, the distance between them is exactly 37 kilometers. So you're finding the time. Yeah. So that happens. Maybe they start from here, everybody start at a different point, right? And they end up that when they're 37 kilometers from each other, the time t is 3 hours. All right. So let's begin. We are given the boat travel from point P with this position vector relative to the Coast Guard station. The boat moved with this bearing at this speed. So find the velocity vector. Okay, again, when they give us bearing and they give us speed, we know we can break it up into two components. So where's 3, 2, 3? 3, 2, 3 should be here. More than 270. 3, 2, 3. If you subtract, it's 50 what? 53. Isn't it 53? So it has two components, horizontal and vertical. So the horizontal, we call it A, vertical, we call it B. Your A should be negative, B is positive. The speed given as 20. So your A, right, you need to put a negative, is negative cos 53. Sorry, I need to put a 20 in front. Negative 20 cos 53. Yeah? You can use cos 53 equals negative A over 20. Also can. Yeah, negative 20 cos 53. Calculator. Let's do this. 20 cos 53. 12.0. I'll just take negative 12. Negative 12. The reason why it's negative, because it's on the left-hand side. Right? Okay, let's look at B. B is positive because it's going up. So B is your vertical component. We write sine 20 sine 53. Calculator 20 sine 53. You should get 15.97. I'll take 16. 16. So therefore, your position velocity vector. Now we're supposed to write in column vector. I and J form. And the question says nearest integer. That's why I round it off. So write negative 12i plus 16j. Yeah, that is your part A. All right, part B, write down the position vector of the boat t hours after leaving point P. Okay, your starting position is the boat. I'm going to call it OB lah. Yeah, OB is the final position. Your starting position is P. Where's P? 28i minus 9j plus t. What's your velocity? Minus 12i plus 16j. Can we multiply inside 28i minus 9j minus 12ti plus 16tj? Put them together, 28 minus 12t bracket I followed by minus 9 plus 16t bracket j. That is your OB, okay? Position vector of the boat. Okay, now then they say point Q has this position vector relative to O. The boat continues to move until it's due north of Q. Okay, due north of Q. Okay, if you want to imagine how this looks like, right? Where's 28 minus 9? 28 is to the right, minus 9 is below. This minus 12 16 represent the velocity. You go like that. So at one point, you'll be north of Q. Where is Q? Q has the position vector minus 11, 2. Minus 11, let's say, is here. 2 is here. So Q is here. The boat at one point, you'll be exactly north of Q. Can you see that? Can you understand my drawing or not? It goes, okay, because it starts from here. This is your P. The boat starts from point P. This is your OP. But it's going in this direction, PB. It's going this velocity. So at one point, you'll be exactly north of Q. So that means your QB will be a multiple of J. It doesn't go left, go right. It just say up, right? But we first need to find what is QB. And QB will be OB minus OQ. All right. Well, I actually, like I say, I don't like to write in column vector in IJ format, but we have to find this. They say find the displacement of the boat relative to Q, which is your QB, right? So OB really have 28 minus 12 di plus minus 9 plus 16 dj. You minus your OQ. What's your OQ? Your OQ is given as minus 11i plus 2j. Okay, minus becomes plus. So your 28, right? You plus 11 is 39 minus 12 di, sorry. Minus 9 minus 2 is minus 11 plus 16 dj. I got my OQB. Now, when will the boat be exactly north of Q? When your QB is 0i plus lambda j. Now, why do I use 0i plus lambda j? Remember, if I don't go left, I don't go right, your I component is 0. I just go up. It'll be a multiple of j. I call it lambda j. You can use hj, kj, up to you. But normally we use lambda or mu for vector. Okay, we don't use a Roman alphabet, we use a Greek letter. So this thing here, see the QB on top? We compare our I component. What's your I component here? Compare our I. To find the distance, I need to find the time first. Compare your I component. 39 minus 12t, let it be 0. 12t is 39. 39 divided by 12. 39 divided by 12. Answer is 3.25. 3.25 hours. Okay, so once you got this 3.25 hours, we take this and sub inside your J component. Okay, look at my J component. My J component on the left is lambda, right? Look at this one. This one is lambda. Look at this one, minus 11 plus 16t. So I'm going to write minus 11 plus 16. My t is 3.25. So we will take minus 11 plus 16 times 3.25. You should get 41. Your lambda is 41. Okay, so if your lambda is 41, right, what's your QB? QB is 41J. So meaning, see, Q to B is going up here. It's going up. The difference is what? 41 kilometer, right? So the distance of QB, which is the magnitude of QB, is just 41. 41 what? 41 kilometer. So in this question, the unit for length and velocity are in meter and meter per second respectively. Relative to point O, position vector of A and B are given. So a man runs with this velocity vector, right, from point A. Find the position vector of the man 6 seconds after leaving point O, after leaving point A. Okay, now here's the thing. He starts from point A. He doesn't start, he starts from point A, right? You need to write OA, sorry, I should call the man as OM, equals to OA plus TV. Your OA is 7 minus 12. Time is T. Time is how many seconds? 6 seconds. Your velocity vector is 3, 1. So let's put it together. 7 minus 12 plus 18, 6. 7 plus 18 is 25. Minus 12 plus 6 is minus 6. I got the position vector of the man after 6 seconds. Next one, write down in terms of the position vector of the man relative to point B. Okay, relative to point B, remember, again, you can draw it up. Where is the man? 7 minus 12 looks like this. 3, 1 is 3 to the right, 1 up. So the man goes like that. Okay. So at one point, this is your starting position A. The man could be here, could be here, could be here, could be here. It's moving. Now point B is 23, 15. 23, 15, maybe 23 here, 15 here, I don't know, right? So maybe at the time the man is here. So we call it M. This is point B. So relative to B is BM. Remember, if I say point A relative to O, we call it what? OA. The man relative to B, we say BM. Not MB, BM. Right? Relative to a point, we start from that point. Okay? So, we are finding BM. Now, we know your OM. We know your OB. So, BM will be OM minus OB. My OM, okay, your OM you need to write in terms of T. Because they say T second. Okay, we write your OM as 7 minus 12 plus T, 3, 1. Your OB we already have. OB is 23, 15. Put it together, your BM will be 7 minus 23 is negative 16. Minus 12 minus 15 is minus 27 plus, this one at times inside 3T and T. Put them together, minus 16 plus 3T minus 27 plus T. Guys, I got BM already. Okay, this is the position vector of the man relative to point B. Now, next, find the length of time for which the man is less than 25 meters from point B. So, less than 25 meters means the magnitude is less than 25. So, we use displacement, magnitude of displacement is called what? It's called distance, the distance, right? So, we take negative 16 plus 3t, we use the magnitude, we square this, put the square root over, result less than 25. So, I'm going to square both sides, solve this quadratic inequality. 16 squared is 256, 16 times 2, 32, 32 times 3, 96, 3 squared is 9, 27 squared, oh big number, 27, if I square it, I got 729, 2 times 27 is 54, times t squared is 6, 25 squared is 625. So let's simplify this. 9t squared plus 1t squared is 10t squared, minus 96 minus 54 is minus 150t. Now, this 256, you need to add with 729. Then you minus 625. You should get 360. Now, what I can do is I can divide everybody by 10. Can we factorize this? What is the factor of 36? To get 15. 12 and 3. Right? 3 and 12. Less than 0. It's moving along this line. Okay, so point B is around here. So today if I draw a circle, it's like this. At one point, the man, when he's here, the distance from the man to point B is exactly 25. When it is here, sorry, very ugly, another 25. It can, more than this time, it will be beyond 25. It is more than 25 kilometers. Less than this period of time is less than 25 kilometers. So there is a range of time that it is within 25 meters from point B. So normally we should solve it by using quadratic inequality. You can see here, the two t values are 3 and 12. Less than 0 means normally when you solve quadratic inequality, we shade this region, move it up. We say t is between what? T is between 3 and 12. However, because the question asks for length of time is duration. Between 3 and 12. 12 minus 3, the difference is 9. Answer is how long? 9 seconds. This is, the unit is in second. So for 9 seconds, the boy, or should I say the man, is less than 25 meters from point B. After 9 seconds, it will be more than that, right? So it's going here. At this point, t is exactly 3. For 9 seconds, it stays less than 25 meters, sorry. After t equals 12, it stays further than 25 meters from point B. So in this question, all lengths are in kilometer and velocity in kilometer per hour. A ship sailed from point O, right, with a speed of 51 kilometer an hour, right? So in this direction. So when you're given speed and you're given direction, we can find velocity. I like to use the magnitude vector, it's easier. Velocity, it goes in this direction, so it's parallel to this. So I'm going to write this as 15 minus 8. Again, I like to write in column vector, easier to write, yeah, easier to see. Okay, rather than writing ij, you could underline and so on. Right? So the magnitude of your velocity is what? 51. So how do you calculate your lambda? We take 15, we square root it, negative 8, square root, this is 51. 15 square, 8 square, square root is 17, lambda is 51. 51 divided by 17, lambda is 3. So your V is now 3 of 15 minus 8, multiply inside 45, negative 24. All right, I've got my velocity vector ready. You can write in this form, write IG form, also okay. Now, next, write down the position vector of the ship at time t hours after leaving point O. Now, the ship starts from point O. So you don't have to write another position. Like, normally we write OS equals to OA plus TV, correct? That is if your starting position is A. But here your starting position is at O. So you write OS equals what? T. What's your velocity? 45 minus 24. You don't have to put another position vector in front, yeah, because it starts from point O. So let us multiply inside 45t minus 24t. I got my OS already. Okay, 1 mark only. C. At the same time, the ship sailed from point O. The boat sailed from point A with this position vector and this velocity vector. Write down the position vector of the boat t hours after leaving point A. Okay, so the boat, right, I call it OB. It starts from point A, so it's OA plus TV. Okay, right, so we know your OA, right? What's your OA? Position vector is 18.7. What is your velocity? 32 minus 21. So we can put them together, 18 plus 32t, 7 minus 21t. That is your vector OB. All right, lastly D. Find the distance of the boat from the ship after 2 hours. Okay, boat from the ship after 2 hours. You can find your OB first, your OS first, then you just find BS or SB, then find the magnitude. Okay, so I'm going to sub T equals to 2. What's your OS? After 2 hours, 45 times 2 minus 24 times 2. This is 90, negative 48. Do the same for OB. So this is 18 plus 32 times 2. 7 minus 21 times 2. 32 times 2 is 64. 64 plus 18, that would be 82, right? 7 minus 21 times 2, 42. 42 minus 7, negative 35. Now, I've got my OS, I got my OB. I need to find distance boat from the ship. So we can call it SB. We can actually call BS also, no problem. SB means from the ship, you go to the boat. Yeah, ship to the boat. BS is boat, you go to the ship. Okay, whichever, doesn't matter because we are finding the distance anyway. So we take OB minus OS. My OB is 90 minus 48. My OS is 82 minus 35. 90 minus 82 is 8. Minus 48 plus 35 is negative 13. So it's 8 minus 13. To find the distance, we take the magnitude. 8 square. Okay, I wrote the other way around. Yes, it's okay. Good. Yeah. But the answer is going to be the same, but it's okay. I better change it. OB first. Thank you. OB is 82 minus 35. OS is 90 minus 48. So this is negative 8 and 13. So Magnitude SB is negative 8 squared, 13 squared square root. That will be, calculator, 8 squared, 13 squared, square root 233, right? Or we change it to decimal, 15.3. Yeah, 15.3 what? Kilometer. That's it. In this question, all lengths are in meter and velocity in meter per second. Relative to origin O, the position vector of point A and B are given as this and this. So particle P travel from point A with this velocity vector. So find position vector of P t second after leaving point O. After leaving point A. So what do you do first? Okay, position vector of P. We know we can write OP equals to your starting position is OA plus TV, right? What's your OA? Your OA is 9, 11. Okay, September 11. What's your velocity vector? 5 minus 3. Put them together, 9 plus 5t, 11 minus 3t. I got my vector OP already. Okay, 1 mark only. B, express magnitude of dB in this form of PB. Yeah? So you need to find OB. To find PB, we use OB minus OP. We already have OB. This is OB, right? So PB is OB minus OP. My OB is 16.7. My OP is 9 plus 5t, 11 minus 3t. So put them together. 16 minus 9 is just 7 minus 5t, 7 minus 11, negative 4 plus 3t. I got my PB already. So let us take PB, find the magnitude. Now here they put in a square form, so you don't have to put a square root, right? We take your x or your I component, we should call it I component, we square it. Your j component, we square it. Expand the bracket, 7 squared, 49. 2 times 5 times 7, that's 70. Yeah? And then 5 squared is 25. 4 squared, 16. 2 times 4, 8. 8 times 3, 24. 3 squared is 9. 24 plus 9, 25 plus 9, 34. Minus 70 minus 24 minus 194, right? This is minus 94. Okay. Wait, let me write nicely. Minus 94t, 49 plus 16 is 65. Okay now. So yeah, very ugly number, but we already expressed in this form, no problem. Now, hence determine whether P will pass through B. Okay, how do I do this? Okay, I hope you understand this. PB is a variable. Can you see? It is a variable, right? Maybe we can say OP is here. It goes like this, right? This is O, this is P. B is here. Now, B, we don't know whether, what is the distance of PB? Now, if P will pass through B, right? Meaning B could be on the line. If B lies on the line, what is your PB? The magnitude of PB should be 0. Yeah? If P passes through B, magnitude PB should be 0. So meaning we should be able to solve this equation. Now, if you cannot solve this equation, means P will not pass through B. Now, do you need to solve the equation? No. What do you do? What is the concept that we have to use to test whether it has solution? B squared minus 4AC, the discriminant. We do our B squared minus 4AC. Your B is negative 94. We square it, right? Okay, should I write this? Okay, should I write this down for you? I write this whole thing first, this one. 34t squared minus 94t plus 65, let it be 0. If P passes through B, there will be solution. We don't know whether it got solution or not. We go do our B squared minus 4AC. Negative 94 square, A is 34, C is 65. So let's count. 94 squared right? 94 squared minus 4 times 34 times 65. Your answer is -4. Ooh, less than 0, right? Less than 0 means what? There's no real root. So we say no solution. So if there's no solution means what? Therefore, P will not pass through point B. Okay? In this question, all lengths are in meter and velocity in meter per second. Particle P travel with a constant speed from origin O to A with this position vector in 8 seconds. So write down the position vector P t second after leaving O. Okay, so imagine this. Your particle starts from point O. Well, where is 56 negative 32? 56 negative 32 means like this, around here, 56 negative 32 in 8 seconds. So it is point A, this point O. It travels from here to here in 8 seconds. So that is your displacement OA. So if you want to find velocity, we must take displacement divided by time, right? So can I find velocity of the particle? Okay, I start with displacement is 56 negative 32. I divide by 8. Now, instead of dividing by 8, guys, instead of dividing by 8, we times 1 over 8. So 56 divided by 8 is 7. 32 divided by 8 is -4. So this is your velocity. Now, next, remember you're finding position vector. So position vector of P is OP. Your starting point, I don't know, right? Maybe your starting point is O, so we don't write. You take the T multiply with your velocity. Remember, normally we say OP equals to, let's say, OQ plus TV, where Q is your starting point. But here your starting point is O. So you don't have to write, you just take T multiply with the velocity that would do it. Now here, I would multiply the T inside. I get 7T minus 4T. That's my OP. All right, next. At the same time, particle Q moves from point B with position vector of this and travel with this velocity. Write down the position vector of Q. So this one is okay. OQ equals to your starting point is what? OB, which is minus 1260 plus T, your velocity is 8 minus 9. So put them together, minus 12 plus 8T, 60 minus 90. Okay, I got my OQ. I got my OP, I got my OQ. Okay, next, what do I do? The question say, show that both particles meet and find the position vector at which both particles meet. Okay, so when they meet, your OP mass equals to OQ. They share the same position vector. So we take our OP, 7T minus 4T, equate with my OQ, minus 12 plus 8T, 60 minus 90. Can we compare? Now, they say show that they meet. We cannot just compare one. We need to compare both to show that they have the same time when they have the same x direction and y direction, right? X direction means they are both going to the left and right at the same time, up and down at the same time. So we need to compare both I and j and show the t values are equal, right? So the first one, I compare my I value, 7t is minus 12 plus 8t, bring over t is 12. Then you compare our j component, minus 4t is 60 minus 9t, 5t is 60, t is 60 divided by 5, t is equals to 12. So notice the t values are equal, right? So therefore we can conclude that both particles meet. Both particles meet. Okay, now how to find position vector? Take the t value, sub inside. You can sub inside OP, you can sub inside OQ, either way. But I like OP because it's easier, right? Less thing to count, right? We take 7 times 12, followed by minus 4 times 12. 7 times 12 is 84. Minus 4 times 12 is negative 48. In this question, I is unit vector due east, j is unit vector due north. All distances are in kilometer. The position vector of town B from A is this. Town B from A is your AB. Okay, this is your vector AB. And K is a constant. A car travels from town A on the bearing of 150 at 80 km/h. Find the velocity vector of the car. So we've done this a lot of times, right? Velocity vector 150. Where should I draw? 150. So it's 60 here because 150 minus 90 is 60. So it's in this direction. So it goes at 80 kilometer an hour. It has horizontal component, vertical component, right? So yeah, this 150, 150, you must minus 90 to get 60 here. So we know we can find A first. A will be 80 cos 60. So cos 60 is half, 80 times half, A is 40. For B, right, you need to put a negative. Why negative? Because it's going down, right? Your J component is negative, so we take negative 80 sine 60. Sine 60 is sec 3 over 2. You can actually type in your calculator, so you get negative 40 sec 3. So therefore, my velocity of the car is 40 minus 40 sec 3. Yeah, that's your velocity vector of the car. Now, at the same time, a lorry travels from town B with this velocity. Find the position vector of the lorry from town A after T hours. So the annoying thing or the confusing thing is that normally we use OA. Normally we use point O as a reference point. Now we use point A as a reference point, right? So normally we say, okay, let's say OB equals to, what do you write? The starting point is OA, right? OA plus TV, right? Okay. That's what we write normally, right? Okay. Wait, because you're finding position vector of the lorry from A, so we don't write OB. We write what? We write AB. AB, right? Okay. The lorry start from town B, right? Where is town B? Here. So instead, okay, maybe I don't write this as AB, I write AL. Why? Lorry, we normally write OL. Let's say start from town B plus TV. But then we are not using point O as a reference point. We're using point A as a reference point. Sorry, looks a bit confusing. AB plus TV. Okay? Instead of using O, we use A. Let me write down AB plus TV. Do you know what's AB? Yeah, here. 21K. I know this already, right? So this is 21K. You know the velocity vector? Yes. 25 minus 45. Put them together, 21 plus 25t, k minus 45t. That's your AL. AL represent position vector of the lorry from town A, right? Okay, given that the car and lorry meet, find the time taken and the value k. Now, when will they meet? Okay, first of all, do you have the position vector of the car? You don't have, so you find that. Now, the car also starts from which point? The car travels from town A, so I say AC. Like normally you say OC. OC means you start from O, right? Now we are measuring from A, so it's AC. AC is TV. What's your V? Velocity 40 minus 40 sec 3. Can we multiply the t inside? 40t minus 40 sec 3t. Now, when will they meet? When the car equals to lorry. AC equals AL, right? Because both are measured from point A, not point O. So that's the confusing part. Now, your AC is 40t minus 40 sec 3t. Your AL is 21 plus 25t, k minus 45t. Can you equate them? 40t equals 21 plus 25t. Bring over 40 minus, I'm comparing the I component. 40 minus 25 is 15. 15t is 21. 21 divided by 5. Everybody, 21 divided by 15 is 7 over 5 or 1.4. 1.4 hours. Okay. Now, we're finding the time. And we're also finding the what? The k value. So we compare our j component. Negative 40 sec 3. Time is 1.4. equals to k minus 45, 1.4. Find k here. So this one a bit annoying. You have to type in your calculator. So we take negative 40 sub 3 multiply, put it outside, multiply 1.4. Bring the 45 times 1.4 over 45 becomes positive. I cut short my working a bit. So my answer, change to decimal, negative 33.99 is negative 34. Yeah, I purposely work out a nice number, right? I want to get a nice number. So yeah, 1, 0 is unit vector due east, 0, 1 is unit vector due north. So unit for length and velocity are kilometer in kilometer per hour. A cyclist travels with this velocity vector from this point. So find the bearing on which the cyclist is heading. Okay, so be careful with this because sometimes some people misunderstood. What is the difference between bearing of the cyclist where he's heading, where the cyclist is heading, versus bearing of the cyclist from point O? So picture this. The cyclist starts maybe from this point, 23, 4, maybe here, right? Velocity vector 9, 15. So it's going this direction. So actually, the cyclist starts from a point, let's say point A, but it's going in this direction. Okay? So if, let's say, the cyclist, for example, travel from A to B, if they ask you, what's the bearing of the cyclist, maybe here, from point O, then we are actually finding this bearing. But if the question asks for bearing on which it is heading, we are actually taking the direction of the velocity. We're finding this bearing. It's two different things, right? We're finding the direction of AC. A is the starting point, C is the position of the cyclist. We're finding the velocity, the direction of your velocity. So in this case, let's take a look at our velocity. What's your velocity vector? Your velocity vector is 915. 915 means I go to the right by 9, I go up by 15. So this is your velocity vector. We are finding this bearing, this angle theta, right? Okay, so normally I don't write theta this way, guys. Normally we just find respect to x-axis first, then we do 90 minus later, all right? So let's start by taking tangent. Theta is 15 over 9. Use your calculator, shift tangent, 15 divided by 9, 59.0, yeah? 59.0. Okay, if this is 59.0, your bearing will be 90 minus 59.0. You should get 31.0. Yeah, 31.0. All right. Okay, so that's part A. Yeah? B. By the way, sorry, for bearing, right, you need to put a 0 in front. We cannot just write 31. We need to put a 0 in front. Okay. All right. Second one. 1 hour after the cyclist start to move, a motorcyclist move with this velocity from this point. Okay, so find the position vector of the cyclist at the time t hours after the motorcyclist start to move. Okay, this one is very, very interesting because the time is different. Cyclists start to move first, right? Motorcyclists start to move later. T hours is measured after the motorcyclist start to move. So for example, if the motorcyclist start to move for 3 hours, yeah, motorcycle move for 3 hours, cyclists will move for 4 hours. Cyclists travel longer hours compared to the motorcyclists, right? So you need to use T plus 1, okay? So for the cyclist, I'm going to use OC. Your starting position is what? Starting position is 23.4 plus time. Time, you don't write T up, we put T plus 1 multiply with the velocity vector 915. Why T plus 1 again? Why T plus 1 again? Because it travel 1 hour more compared to the cyclist. Alternately, right, what you can do is you find some students, they do like this. They say, I take 23.4 plus 1 hour times 915. I get this answer. Then I find the position vector of the cyclist again, plus T, another 9.5. Take this answer, put inside. Also can. But basically, you just plus 915. One more 915, right? So, okay, let me just simplify this. This is 23. For this one, maybe we times in directly. I times in directly. This 9t plus 9. This will be 15t plus 15. Put them together. 23 plus 9 is 32 plus 9t, 19 plus 15t. I got my vector OC. Okay, everybody, I got my vector OCD. All right, now next, what I can do or what I need to do is to find, this is simplified answer, I got this already. Okay, find the time taken by motorcyclists at the instant it starts to move until it meets the cyclist. So when would they meet? When the motorcyclist, position vector of motorcyclist equals to position vector of the cyclist, right? So we find position vector of the motorcyclist first. So motorcyclists start from which point? 1638 plus t. Velocity vector 57 minus 42. Put them together. 16 plus 57t, 38 minus 42t. Okay? Right? Now, next, we know they meet, right? So they meet when OM equals OC. My OM is 16 plus 57t, 38 minus 42t. My OC is 32 plus 9t, 19 plus 15t. So we need to compare, right? Compare your I component, 16 plus 57t equals 32 plus 90. So bring this over. Wow, the time a bit short, right? 57 minus 9, that is 48t. 32 minus 16 is 16. 16 divided 48 is 1 over 3. Right? Now, if you compare your J component, you are supposed to get the same answer. Let's just validate. 38 minus 19. 38, well, this one is ugly. Let me fix it. 38 minus 19 is 19, correct? 42 plus 15 is 57. 57, if you divide it, is still 1 over 3, right? So now this 1 over 3 is in hours, right? Well, the question never say you have to give your answer in because the question says it's per hour, right? So you can actually write 1 over 3 hours, or you can convert to minute, right? Question never say give your answer in minute. So I just write 1/3 hour, which it makes sense, right? Yeah, it's not going to be like 4 hours, 5 hours. It's going to be like 1/3 of hours are 20 minutes. Yeah, in 20 minutes, they will meet. If this video helped you, you can get my advanced book from Shopee or Lazada or by searching teliti. For full step-by-step learning, check out my e-course or join my classes at Pusat Tuition Teliti. Remember to like, subscribe, and share. See you in the next video.